Today I'm going to be talking about HA in the StarlingX project, building resilient systems and lessons we've learned from high availability architecture. So my name is Eliud. I'm a software engineer. I work for Wind River at the moment, and these are my links. So this is a roadmap of what I'll be talking about today. So I'll start off by giving an overview of the StarlingX project, and then I'll talk a little bit about critical infrastructure services or platform services. And then finally, I'll discuss a few of the common challenges that we faced, and then we'll cover some solutions that we've addressed, and then I'll finish it off with a QA. So, what is the presentation about? This presentation will cover implementation of StarlingX, and will highlight some of the real-world lessons that we have in deployments. I'll discuss what HA means to us. Essentially, the goal of HA is to create an environment, a computing environment with negligible downtime. And if you get an error, you should have like very little time in recovery. Right? The scope of this presentation will not be all of HA. It will just be HA on controller nodes for critical infrastructure services. And some of the services that we're trying to maintain low downtime are things like Docker, Ceph, RabbitMQ, Postgres, HA.c, DNS maps, etc. And then finally, I will summarize some of our key insights. Like we achieve HA through a combination of some architectural choices and dedicated system services. And finally, we prefer to go with a data-driven approach. And I'll also talk a little bit about how to distinguish between connectivity issues and performance lags. So, start with the overview. So we have a variety of deployment configurations in StarlingX. We have the Ceph all-in-one deployment configuration where we have all functions in one node or one server, controller function, compute, and storage. Or you can have, that doesn't give you HA, at least from critical infrastructure services. So the next deployment configuration is the beginning of your HA, where you have two all-in-one servers providing high availability, and each server has all functions as well, compute, storage, and control functions. And then this is probably the better deployment where you have dedicated servers for each function. You have two controller functions and then multiple storage and multiple compute, and storage and compute can scale appropriately based on your budget. And what's becoming really popular, but is beyond the scope of this presentation, is distributed cloud, where you have a system controller, and you can have HA on the system controller. Then you can have subclouds in different regions, and those can also be, and I think we've achieved almost, 100 subclouds being managed on scale.
Sorry, just one question. What's your differentiation between controller function and system controller function?
So the system controller is essentially managing the subcloud, so it doesn't have heavy workloads, but like the controller, say in the subclouds, if you have compute nodes, so the workload will be at the subcloud, not at the system controller. Okay. Yeah. Any other questions? Okay, good. All right. And this is just an overview of the StarlingX project. So we have our OpenStack component layer, we have our Kubernetes components, and then this would be like our core services in what StarlingX provides on top. It's like we have configuration management, fault management, host management, which is a group of services, service management, which is what I'll be focusing on in this presentation, and that's what really provides a HA for the core infrastructure services, and then software management for upgrades, up-versioning, and whatnot. And then at a lower layer, although they're technically managed by service management, is all the ones you're familiar with, Ceph, Keystone, etcd, Docker, and all this is currently on a Debian OS. I think we're on Bullseye? Trixie, sorry. Okay, so I'll talk a little bit about the critical infrastructure services. Sometimes we refer to this as platform services too. Okay, so we have host management, which is a variety of services, and essentially they monitor the processes, interfaces, resources, sensors, talks to the BMCs on the server, and interfaces with the other StarlingX services, fault, service management, orchestration, and config. Tends to use a standardized state management model with lock unlock, disabled enabled, and when you're starting up you go from offline, online, and depending on whether you start up properly, you either be available, failed, or degraded. Anything particular here? It's essentially host management manages the server, detects if there are issues on the server, sensors, power, whatnot, and talks to the BMC. And then what I'll generally be focusing on is in the service management area. So you have an active standby model, and then we tend to have a redundancy model. It's usually in n plus m or n, where n is the number of active nodes, and m is the number of standby. Currently, we only have 2 controllers, but the software is written in such a way that you could have n controllers. So for now, it's 1 plus 1. And what Service Manager offers you is the ability to monitor multiple services, and in order to achieve a low footprint, we use scripts, simple Linux scripts, either LSB or OCF, standardized Linux scripts. And another thing is the communication path between the 2 nodes is on multiple communication paths. So if you lose one network interface, you still have connectivity on the other. Okay. So I'll talk a little bit about the common challenges that you get from HA. The most obvious one is you want to avoid a single point of failure. So that could either be hardware, software, or your network. And this is generally a continuous effort. Another common one that we seem to be experiencing a lot is infrastructure overload, where like your compute can take up all your CPUs, and then the service management or the ability to achieve HA is lost because you're working on stuff and your CPU gets a bit overloaded. Another concern is network latency. If your network is slow or your routers are not responding, so you have to be able to create a HA solution that can deal with low latency or network latency, and it doesn't have to be consistently low. There might be periods of network latency. And finally, you want to be able to recover or have a real-time response, and this should be automated so the user doesn't notice, it just happens, right? So those are architectural and system level challenges. We also have operational challenges. Like the most obvious thing is to achieve redundancy, you can just duplicate everything, but that's expensive, so you have to balance cost versus redundancy. And when you're up-versioning or upgrading, you don't want to have downtime. So you have to maintain your HA while it's getting upgraded. Okay. So I'll talk a little bit about solutions. So this is sort of like the way we approach HA. We take a data-driven approach. Everything is configurable. The services that are going to be running, their active standby model will be configured. We monitor all the services using these Linux scripts that I mentioned earlier. We have multiple communication interfaces, and on those communication interfaces we maintain a heartbeat. We have security and authentication, HMAC 512, and in some network interfaces we have IPsec. And then we also maintain a service state dependency tree, so if one service depends on another, you can't activate or enable it until the other one is enabled. Let's see if I can describe that a little bit better. It's a bit wordy, so bear with me. So we have, in the model, we have services, like Postgres, Keystone, Ceph. Then we have service groups, which is kind of like a conceptual idea of where they fall, like storage services, cloud services, web services, controller services. Then we have service domains, which are associated with the function of the node. So in this case, we have a controller aggregate domain. And then in the controller aggregate domain, that's where you set up, there's only one service group per domain. So there's one cloud services, and the cloud services would either be active standby or active active. This table might help a little bit better to explain. So for example, these are actually real services in StarlingX. This table is it's not one table, it's many tables, but I've collapsed it into one for explanation. So for example, OAM services, like your OAM network, uses a script called IPadder2, and it uses a active standby model, versus say Ceph. The Ceph service is in the storage services service group. It uses a Ceph init wrapper script, and it's an active-active model. Or Horizon, which is a web service, is also an active-active model. And then I have an FSM to just describe how the service state machine works. You start in an initial state, you go into an active state, and then depending on the response from the script that's monitoring the service, you can either go to standby or disabled or back to active. Okay. All right. And then finally, I'm just going to touch on one of the things we deal with in HA quite a bit is sometimes you might think you have network lag, but you actually have a performance issue. And in order to achieve that, you have an internal heartbeat, which is this one. And the internal heartbeat is maintained between the heartbeat agent and the service manager. And if that goes down, then you know you have a performance issue. Whereas we have heartbeat messages between both service managers on multiple networks. And then depending on the results of those heartbeats, you might be able to calculate the health of the controller and determine if you have to switch from one controller to the other automatically. And additionally, we have a cluster heartbeat if you have the nodes, like a storage node or a compute node, that is broadcast to both controllers, and the view of both controllers will tell how healthy it is, and they'll determine who should be active. Yeah. Okay. All right. That's it. Any questions?